Okay, guys, Assalamu alaikum. My name is Mohammed Gyashuddin. Today I'll discuss about differentiation. Differentiation. Okay, and for knowing this differentiation, you have to know some formula related to limit. Okay, first one, the formula of limit we have to know. And first formula is limit x tends to 0, x tends to 0 sine x over x. Almost. What is the amount of this formula? Limit x tends to 0, sine x over x equal to 1. Try to remember always. It's equal to 1. This is actually a formula. Whenever you just going to solve the problem, then and then you have to use this formula. And I will prove this later. Just like this, another formula, same is same actually. Just you take this x tends to 0, x sin x equal to 1. Same this formula and this formula same. Okay, and another formula which is same. Just limit x tends to 0, x tends to 0. Here sin x, just 10x, 10x over x. What is the value? What is the limit x tends to 0, 10x over x? What is the value? Same 1. Okay, just try to remember this formula. It will be applicable when we solve any type of problem. Okay, there is another formula, same. Just you take this limit x tends to 0, x tends to 0. Okay, limit x tends to 0, limit x tends to 0. Just you take x as a limiter and 10x. What is the value of limit x tends to 0, x over 10x? What will be the value? Same 1. Okay, this 4 formula you have to remember. Okay, for doing mathematics. There is another some formula I will show you. Okay, what is ex minus 1 over x limit x tends to 0. Limit x tends to 0. X minus 1 over x. What is the value? Is 1. Yes. Okay. Understand? And limit x tends to 0, e to the power x. Sorry, a to the power x. A to the power x minus 1 over x. What will be the result? This is actually a formula. Just to remember this. This will be ln a. Okay, this will be ln a. Another formula I will show you, that is how can we prove? Just now I have said this limit x tends to 0. What is this? Sin x over x equal to 1. How we can prove this? How we can prove this? Limit x tends to 0, sin x over x equal to 1. We have to prove this, and for proving this, we have to know some formula. Actually, I have given you, I have given you just now a lot of formulas, and which I am going to prove now. But for proving these formulas, I have to know some equation, some formula. Okay, we have to remember this. And which are those? There, guys. This first one, e. What is the value of e? What is the series of e? You know, what is the series of e? What is the series of e? Is very easy. Always try to understand. And what is e to the power x? E to the power x. What is the series of e to the power x? You know, anybody? What is the series of, what is the elaboration of e to the power x, or e to the power minus x, and what will be the a to the power x, a to the power x. Anyway, at first, to do this, then I will make you understand a to the power x. What is the actually series of a to the power x? Does anybody know? Anyway, just simple hint. No index. E to the power x, e to the power minus x, a to the power x, or e to the power minus x, or a to the power x. Okay. Please let me delete all. Now, would you able to say me e to the power equal to what is the series? E series equal to first one plus 1 over 1 factorial. Okay. 1 factorial plus 2 factorial, and numerator 1 plus 3 factorial, 1 plus dot 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 dot. This is the series of A. Please try to remember this. E equal to 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus dot 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 dot. Okay. And this is E equal to. And now we have to say what e to the power x. What is the series of e to the power x? Would you able to tell me? Do you remember e to the power x equal to what is the series? It's very simple. All are same. All are same. Just 1 factorial. 1 factorial, you just put 1 plus 2 factorial, that is square. Okay. And plus 3 factorial, that means x to the power cube, x to the power cube. Okay. Dot, 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 dot. So where this series will go. Okay. And yeah, guys, can anybody say me? Can anybody say me sin x? Sin x. What is the value of sin x? Differentiation. What is the value of sin x? Sin x. What is the value of sin x? What is the series of sin x? Can you say me? What is the series of sin x? Okay, fine. Starting x minus x 3 factorial. Okay, x minus 3 factorial plus x to the power 5 factorial. Such way it will go forward. This series you have to remember. Okay, this series you have to remember. And another series ln 1 plus x. What is the ln 1 plus x? You have to say what is this x, since here 1 factorial of 2 factorial, since 2 factorial, that's why x square plus 3 factorial x cube, such way it will go forward. Okay. And 1 plus x to the power n. What is the formula? 1 plus x to the power n. Could you anybody tell me? 1 plus x to the power n. Could you anybody tell me what is the series, or what is the formula? How can we expand 1 plus x to the power n? How can we expand? What is the expansion? Can anybody tell me? Just this will be like this: 1 plus x to the power 1 factorial n. Okay. 1 factorial, sorry, since n x. Okay. 1 plus, again I delete this, n 1 factorial x. Just remember and try to follow this. Okay. 1 plus x to the power, and if you write 2 factorial, okay, if you write 2 factorial, then n minus 1 x square. Okay. And if we write 3 factorial, okay, you have to write so n minus 1, n minus 2, and such way this expansion will go forward. Okay. Anyway, there guys, I have given 3, 4, 5, 6 equation or series I have given. Okay. Now I will give another formula, a to the power x. What is a to the power x? What is the series of a to the power x? Can anybody say me? I have to remember this actually. 1 plus 1 factorial plus 2 factorial. Since 1 factorial, that means you have to write down ln a. Ln a. Okay. And since ln a x. Okay. Ln a square. And this is square. Okay. And 3 factorial x cube ln a cube. Such way to go forward. Okay. This series you have to remember for proving the formula. Okay. Now there is let me prove this formula. Limit x tends to 0 sin x over x. We have said this is 1. How do you prove this? Okay, how can we prove this? Limit x tends to 0 sin x over x equal to 1. Okay, and for proving this we have to know this series just now I have given. Okay, sin x equal to, what is the series did I say? X minus 3 factorial x cube plus x to the power 5 over 5 factorial minus this. Okay, I wrote this. Okay, sin x equal to x minus x cube 3 factorial plus x to the 5 factorial. Okay, we have to use this formula here. Then we have to prove this equal to 1. How can we prove this? Let me show you. Just now I have written this. Okay, just now I have written this, so we can write such way. Limit proof. This is actually proof. Limit x tends to 0. Okay, sin inverse x over x equal to okay, limit x tends to 0. X tends to 0 sin x over x. This sin is equal to this and over x. Now we can write x tends to 0. X tends to 0. X tends to 0. X tends to 0. Okay, this. Now we can cut this and this square. Okay, then you can find out limit x tends to 0. My gosh, you not get chance. Okay, limit x tends to sin x over x equal to limit x tends to 0. Here x goes, that means 1 minus x square 3 factorial plus x to the power 5 factorial dot rm. Okay, x tends to 0. Now if we put x tends to 0, x is 0, then we can write down here x square x to the power 4. That means if we put the value x tends to 0, then we can get all are 0. Okay, and we get only 1 minus 0 plus 0. That means so limit x tends to 0 sine x over x equal to 1. This is good. Okay, that's all today. Assalamu alaikum.